Right. Welcome to Automating Change. I'm pretty excited to be here talking to people that are actually interested in this stuff. It's hard to find that, and at least in the company that I'm in, we're kind of the lone wolves. So when we talk to people about kind of automation and the DevOps area, kind of get that glazed over type of like not really understanding what's going on. So this is really exciting for me. I'm really excited to be here, and by the end of this, you'll understand kind of how crazy passionate I am about this space. We've done quite a bit of stuff with this. So diving right into it, I'm definitely going to use all 60 minutes, if not more, but I'll try not to impinge on your lunch too much. A little bit about myself. I have about 13 years in the technology space. I started off as a developer programmer for a large manufacturer of electric motors and generators. I worked actually in their engineering department and not in their IT department. But I always had a running joke of like our company acquired companies like they were collectible cards. It was definitely a growth through acquisition business, and kind of liking that every time that they would acquire another company, it seemed like I would acquire another job. But I kind of took that as a way of learning some of these other areas. By the end of my 8-year tenure at that location, I was doing Java development, and I was developing on multiple platforms. I was actually the primary Linux administrator at the company, and I also managed some of their network appliances like the F5 load balancer and several other things. So I was kind of born into this DevOps through that, kind of getting experience in a whole wide variety of technologies. And that traditional, like, you're a developer, that's all you do. I soon acquired a taste for kind of the big picture, like always been a big picture guy. I was hired on at TASC in 2011 as a Java developer, which is kind of funny because I think I've opened Eclipse maybe 5 times and maybe wrote probably about 10 lines of code. But I was kind of hired on for this position before before DevOps was really kind of a thing at TASC. But they saw the kind of the coverage of my knowledge and decided to hire me on with ulterior motives of kind of moving me into that DevOps space. Currently, I hold the title of DevOps engineer, which I'm pretty proud of because just to have that DevOps in my title, that's kind of a rarity out there right now. Definitely been working in that space my entire tenure at TASC, but only recently have been kind of deemed officially by HR a DevOps engineer. A little about TASC. TASC is an acronym for Total Administrative Services Corporation. We're based in Madison, Wisconsin. We're a nationwide administrator of benefit services. So we're the nation's largest privately held TPA. And TPA just means third-party administrator. So we handle tax advantage health benefit plans for companies ranging from 1 employee to thousands of employees. So we're the people they come to so that they don't have to deal with that stuff. Things like flex plans, very possibly somebody in this room, TASC is your benefit administrator. We have 8,000 field representatives, over 900 associates at Madison, and we're very remote-friendly employer. Me personally, I don't work at the office. I work from home, and they really encourage that. Our technology department kind of sits at about 100 people, 100 employees right now. We have developers, QA, project managers, business analysts, our infrastructure, and also our architectural team. We have stateside support and offshore currently. Our primary drivers for our technology section is our web-based application. And it's how everybody, our end customers, manage their benefit plans, and also how our internal employees interact with our system. So it's all kind of in one. The average usage, we see about 40,000 logins a day in our non-peak times. Our peak times are typically kind of first of the year type of area, and we'll see upwards of 85 to 100,000 logins per day. So, mid-sized company, we see a lot yesterday and today about these large, humongous scaled companies. And that's kind of what leads me into our overview here is really, we've heard a lot about explanations of methodologies, and I think we kind of all understand that. I think what some of us are kind of craving is like, so how'd you do it? And from that standpoint, is kind of what I'm going to walk you guys through. Is kind of our story, our evolution as far as this space goes, and how we went from very manual position to a pretty completely automated setup. So the TASC story is pretty simple. It started with us sitting down and trying to understand what we were trying to really accomplish here. And that was mainly just improvement of these cycles, deployment, testing, delivery, and development, testing, delivery, and deployment. Obviously development and testing, those cycles, deployment cycle. I put delivery in there mainly because of, how you package your application, how do you deliver that? That was kind of a big thing we were looking at as well. And just kind of all of those cycles kind of pushing towards that continuous delivery. And it's kind of the holy grail, buzzword when I first started at TASC. Really understanding that methodology and what it actually was. To me, it's always been kind of the holy grail. I mean, it's there and you want to shoot for it. I mean, you're never going to get probably 100% there, but you want to get as close to it as you can. So the road to improvement, how do we improve all these cycles? We really sat down and tried to figure out what was the one thing that was going to kind of push the envelope in all of these cycles, and not just one. Let's not focus on one. Let's see if we can move them all forward. It really came down to three basic concepts: the efficacy, efficiency, and consistency. And I'll talk a little bit more about how we have used those to improve those cycles here. So what was our first step? Now that we have pretty much identified that we had a general goal of improving these processes, improving these cycles, and how we would want to go about doing that, and what tools we were going to need. So it really boiled down to one thing for us. We knew if we could automate the processes, that they would improve. It's just it was going to hit all those core concepts at the same time, and we could literally do it inside all of those cycles. So riding that road to improvement, really looking at those core concepts and understanding those core concepts. The efficacy, I think something we often take for granted is does your process really hit home, and it's the ability to produce that desired result. Sometimes we lose sight of that. Sometimes we take that and we say, well, obviously we want it to give us the result that we want. But sometimes if you don't pay attention to that, you might start deviating from that intended result, and instead of fixing it, you're going to end up just kind of compromising. So efficacy, just one of those things we definitely want to focus on. Efficiency is where most of us spend our time. The efficiency, obviously achieving that maximum productivity, with minimum wasted effort and result. So we want it to be easy. We want it to be, take less time. We want it to cost less money. That's where we focus a lot of our time as DevOps. How do we improve that? And that's what the business likes the most: saving money, saving time. And for the most part, those are hand in hand. The last thing is consistency. One of those things often kind of overlooked as well, because it ties so much into the efficacy, where, you know, obviously I want to get to that desired result, and definitely the way to do that is drive through consistency. Like, if you have the same process every time, you're more than likely going to get that intended result. So really driving home consistency, unchanging processes. That's what we want to get to. The other things we were looking at was, you know, what's going to really drive process change through an organization. And automation just kind of stood out there. For us, it was like, well, if we can automate it, we can make the easy way the right way. And that was really key. Like, if we can make the easy way the right way, then people are just going to do it. They won't argue about it. They won't, you know, and really providing that, you know, that solution to our end user. And it kind of ties into the last point here, getting buy-in. None of this would be possible without the complete and total buy-in from pretty much the entire organization. For us, you know, the low-hanging fruit was getting the developers, the QA, the technical people on board with it, because they're kind of the knowledge holders. We really wanted to get them to buy in so that we could absorb that knowledge from them and automate the processes they were currently doing. But not only that, but extending it to the business, where, you know, we can show improvement in, again, efficiency, show them some time, show them some money improvement. That was really where we were focused on getting buy-in for automation. So when I came on board in 2011, everything was pretty manual. There was very little automation, if any. And I would say in this diagram, there really wasn't any. Our development cycle, as you can see down in the corner, we at least had source control, which was good, but we didn't really have anything else. The development process was very, very immature. You know, developers would develop code, they would check it in, and nobody would know really the status of the build until one of the developers checked it out to work on some code, and they tried to build it, and it was broken. Nothing to tell you, okay, what broke it, or if they're, you know, narrow it down, and literally would kind of deadlock our development group until somebody figured out, oh, I checked this in, and it was broken, and I'll fix it. You know, obviously, we were a very small shop at the time. You know, the idea of this always still seems mind-boggling to me, that we didn't have anything there and it was just kind of manual. But, you know, from that size company, that's kind of where we were at. As far as deployment goes, quality assurance, the QA group was pretty technical savvy. But basically, when they wanted to deploy to one of our environments, they would have to do that manually. So they would SSH into the server, they would check out the code, they would build the code, they would deploy the artifact, all manual. You know, inconsistencies there, you know, were running pretty rampant, and we basically had 5 lower environments. Here I'm showing 2, but we had 5 set environments. Our staging environment, which we refer to as Model Office, was basically more production-like. It wasn't full-blown production. We did, in Model Office and production, we had load balancer, you know, high availability type of setup. So everything would kind of flow through staging, and we only had 1 staging environment. So if we had multiple projects going on, they would have to negotiate time to do regression testing in the staging environment. So even though, you know, these were all VMs on our VM farm, you know, it was very much static infrastructure. I mean, that's how they were treated like physical servers. And the amount of time it would take to negotiate with infrastructure as far as, say, building a new one, say, you know, to help with that load, you know, it was just, nobody even asked because it would just take too long, basically. So very, very manual. Just reiterating some of the issues we were seeing, that slow development cycles because of the lack of transparency. So, you know, we would see a lot of time spent trying to figure out why the builds broke, or you know, managing those branches of code, you know, different projects using different branches, managing that merging, and so forth. Very archaic and manual testing, just like everything else. was manual. There wasn't any scripting or anything. That was also, and the limitation as far as environments also provided slow turnaround for that cycle, for the testing cycle. Manual, inconsistent, and time-consuming deployments. This was definitely something that stood out, above everything else. Our deployments to the lower environments were obviously inconsistent because you had a developer or you had a QA person performing it, and obviously they're human, and obviously, different people taught it to other people different ways. It wasn't very well documented, which obviously promoted a lot of issues. So it would cause that issue, but not only that, but in production, I would say it was commonplace for us to have 4 to 6 hour deployments. So that's downtime. The application is not available. And this is the application that serves not only our customers, but our internal staff to manage accounts for our customers. So completely down on a Saturday for 4 to 6 hours was common. Lack of knowledge about our deployment process. I remember when I first kind of started down this, just getting somebody to explain, all right, what are all the things that we need to do? I know we need to build the EAR file and we deploy the EAR file, but what are the other steps? And I'd get 5 different answers from 5 different people. So, just that lack of knowledge, of understanding of what our deployment process was poor. Monolithic, static, inconsistent infrastructure. So not only was it kind of, these old stale environments that we had set up, we were starting to see problems with people tweaking configurations. Those configurations never got really checked or refreshed or any of that sort. And also on our database side, if a request came in for database refresh, that means that whole environment's that testing environment's gonna be down for at least 3 hours. And this is time that, taken away from project testing or, whatever they could be using that for. So having issues and limitations as far as the infrastructure goes was a big issue for us. So what are the first steps? First steps towards automation. And, really for us, it came down to, okay, we need to find the tools to be able to do this, really pull this off and pull it off well. It led us to 2 tools, the first of which is Jenkins. And I'll talk a little bit about all these products, but the nice thing is all these guys are here downstairs. So if you have some really, technical questions, that's where I would definitely go. I'm going to kind of tell you what we've done with them and kind of our philosophy on using them. But obviously, some of these products do way more than what we use them for. And like I said, it's just be informed about those products and what they do. And for us, what it came down to is finding the best product for the specific thing that we wanted to do. At least for us, being a small to medium-sized business. The first one we came across, was the obvious choice for, we want to monitor the build, and we want to do it for the low cost of free. So Jenkins was kind of our first stop. All my experience with them has been really, really good. The introduction of that product really brought us some good value. So, built from the build monitoring and testing, and also it was kind of our first dipping our toe into the pool of automation. Really starting to look at, all right, what can we do with this, type of thing. And that really led us to our lower environment deployment process. That was kind of what tipped the scale, and we kind of started playing around with it and being like, yeah, why aren't we doing this? So build monitoring, testing, lower environment deployment is kind of where we utilized Jenkins. The second product that I have up there is Atomic. We actually owned Atomic Automation Engine before any of this started, and we were using it for basically moving files around and glorified cron. I mean, it was a scheduler for us. And for those of you that know anything about Atomic, that's like using a sledgehammer as a fly swatter. I mean, it's overkill. It's like we wouldn't even really need that for those things. But I remember sitting down with, it was probably my first week there, and kind of going through that product with one of our infrastructure people, and just getting that first taste of like, all right, it's a platform that I can use to pretty much do whatever I want. Like, I can interact with any platform server I want, and really started understanding what the tool is capable of, other than scheduling and moving files. We kind of use a two-prong approach when we started development, because our development of our automation, because we didn't really know where it was going to lead. So in the lower environments, we started automating with Jenkins, mainly because it had a nice web front end that the QA could log into and click a button type of thing. In our production environment, it was pretty obvious that Jenkins wasn't going to work for us, just for the complication of that multi-node, being able to do things in parallel, and really maximizing that efficiency. It was pretty apparent that Jenkins wasn't going to do it for us, or at least not the way we wanted to do it. So we kind of started developing out our deployment process in Atomic Automation Engine for production, kind of knowing that was our future. Like, we were pretty sure at the time, like, in order to support the complexity that we needed, that was going to be key. So for us, Atomic Automation Engine became our universal gap filler. That's really what it was. I mean, it was our orchestrator and our gap filler. So if we had a gap that, say we didn't find Jenkins, well, I could pretty much build a workflow that does some build checking, that runs a build, analyzes the results of that build, and can alert somebody if it's broken. Do I want to do that? No, not when I have a free product like Jenkins I could just plug into my system. So the nice thing about Atomic is, I can interact with Jenkins. Since Jenkins has a CLI, I can do scripts and interact with it, which we ended up doing for a while. But it was pretty obvious that Atomic was going to be our future automation platform, and so we really started pushing that. So this is kind of what our layout ended up being. Like I said, this is kind of a watered down, obviously, of our actual production. We are very much a multi-platform. We have a LAMP stack, we have a .NET stack. All of those have kind of followed in parallel with this development, but this is our core application, our JBoss and our MySQL. So as you can see, pretty much, we added Jenkins to our development cycle. So developers would check in code. Jenkins would basically pull SVN, looking for new code, and if there was new code, it would run a build. And then if it was broken, it would email the people that broke it and said, hey, fix it, and alert everybody else that build was broken. So it was just kind of that first step into like really providing that thing that we needed in our development cycle to be more efficient. And then on top of that, we hooked into it, and QA was able to deploy, do simple deployments to our lower environments, which pretty much consisted of Jenkins building the IR file and us moving the IR file and bouncing JBoss. In the lower environments, that was pretty much all we had to do for the kind of testing that they were going to do. And like I said, in production, it was going to be a little more complicated. And obviously, when we have to deploy to 6+ servers, we want to do that in parallel. We don't want to be sitting around waiting for that to happen serially. So what improved? The big things that improved with the Jenkins product were we really, detecting those issues early, so that we didn't have any deadlock where developers couldn't develop until somebody fixed the build. That was really big for us. Increased testing and analysis. There's a plethora of plugins for Jenkins that we use to do unit testing. We have hooks into Sonar for code quality type of stuff, but we've really extended that that product to our benefit. Rapid deployment to lower environments. This was big for QA. The turnaround to be able to deploy instead of them doing all those manual steps. They clicked a button and waited for the email to tell them that it was ready, so they could be more efficient. Obviously, the automation did it probably faster than they could do it manually, but also they could click the button and go work on something else while it was deploying. This was really, although not the most sexy of stuff that we've done, this was probably what got us the most benefit. Just right out of the gate, we got complete buy-in. It saved everybody time, like everybody from QA to our project managers. Just top to bottom, like gave us the most buy-in. And from here, it was just an easy sell no matter what we did. From the Atomic side, it simplified our production workflow, which was complex at the time. What a manual deployment looked like is us starting on one end and basically doing the manual deployment to however many servers that were in our cluster. It was kind of insane. I ran a couple of those when I first started, and it's the last thing you want to be doing on a Saturday. Added some safety nets and health checks. In the workflow, since you're doing it so quickly, there's a lot of things that we would run into during deployments that would always get us. Like, just for an example, like filling a disk, like detecting that early on, like right off the bat. That's one of the first things that we implemented is just to check, say, are any of the disks over 80%? Just simple stuff like that just kind of like totally revolutionized what we were doing. Allowed us to tackle things in parallel, which was big. For us, we went from those 4 to 6 hour deployments to under an hour, which is crazy. And this is what really got the business to buy in. They're like, oh yeah, well, we should do more of this. So not only were our internal tech people buying in, but we had business buy-in right off the bat. So expanding that automation, we kind of just sat down and put some general goals down for the kind of those next steps, and this is what they were. We really wanted to get to a more modularization in our code. At the time, we had this huge ear file. That's basically all it was. Everything was in that ear file. So in order to update anything, we had to take the system down, like systems that don't even really relate to each other, because they were in the same ear file. That really put a cramp in that, trying to get to that continuous delivery. Dependency management was a big one too. Managing those dependencies in a Java application was a kind of a bear. Separating development and deployment cycle. From a PCI perspective, just from a compliance perspective, like there was too much developer involvement in actually getting things deployed to production. And we really wanted to see that kind of draw a line in the sand so that would be separated. And the automation was going to be able to get us there. Unified deployment process. So like I said, we took that two-prong approach, kind of with the knowledge that we need to bring those back together. So the lower environments, we want to be kind of our testing ground for our automation, obviously. So that when we go to production, that it's the same thing. The deployment process is the same. Some of the things that came across our plate were, like, well, why are we doing these health checks in the lower environment when we never have that problem there? It's like, well, you do it because you're doing it in production. So it's just like anything else, kind of unifying that and using that as the testing ground for our automation. Deployment downtime reduction. So we had already cut our deployment time, in a quarter. But we didn't want to stop there. We wanted to see how little we could, or completely eliminate. So this brought up a couple more tools. So we took under the huge undertaking of Mavenizing our Java project, which the development group knocked out of the park. We had one champion in the development group kind of push this through, and I have to say, from a development standpoint, it really changed the game for us. Not only did it give us dependency management, but from a deployment standpoint, we now had an artifact repository. So there was no more checking out the code, building the IR file, deploying the IR file. The IR file was already there and built, and we could basically download it from the artifact repository, any version that you wanted, whenever you wanted. So that was a big thing, not only from our development cycle, but also for our delivery cycle. The introduction of application release automation, their Atomic's ARA product. So at the time, I kind of chuckled because we've always been kind of one step ahead of Atomic, but it seems like every time we go into a new space, they come out with an easy way of doing it, which is awesome for us. We kind of, I remember the day the consultant came in when we first bought the product, and I kind of just laughed and told him he was going to have a really easy time because I had already implemented it. Basically ARA sits on top of Automation Engine, so it basically abstracts the workflows that you do, and specifically for deployment. So instead of having 6 workflows for 6 servers, because I wanted to run them all in parallel in Automation Engine, this basically made it so that you could abstract that into one workflow and with multiple deployment targets. So basically all I had to do was take that level of abstraction out of the work that I'd already done, and it was pretty much plug and play. The web interface was the other big piece for us. It was a way we could expose the execution of the automation to our end users that might not be as tech savvy. And for us today, initially that was our QA department, who were somewhat tech savvy. They could have handled running deployments from Automation Engine, but we kind of wanted to use that as our operations layer, and this provided a gateway into that. And like I said, it harnesses what you're already doing in Automation Engine, which is really nice for us, and it kind of came along at just the right time for us. Yeah. I'll do some at the end. Okay. All right. I'll wait. So obviously our stack keeps growing here as far as our automation tools. So we slotted in our Nexus, Sonatype Nexus, which is a really nice product. So basically now Jenkins would pull for the code, build the code, artifacts would go into the artifact repository, and they would sit here, and basically we could queue that for whatever we wanted to deploy in our deployment process. So, and this brought the implementation of ARA really brought us closer to our user base. So initially, a deployment would have had to be done by a QA person or a developer. Now we could expose it to pretty much anybody who wanted to deploy. So we were able to give them access to, say, a business user wanted to use an environment for UAT testing. Well, they could, as long as they knew, what application and what version of the application they wanted to use, they could deploy. So it was very simple, kind of broadened our horizons there. Operations, for deploying to production, we even used it. Because it gives you the ability to schedule, it gives you all the more capabilities specific to automation of releasing an application. And then, obviously tying into Atomic, this is where you do most of your workflow development, and then you plug in the workflows to the GUI. But this really unified our deployment process, and so what improved with the Nexus? Provided a much more stable development process. Really reduced the amount of times that we built, ran a build. Once that version was built, it was already in. So there was in the repository, so we could just deploy the artifacts instead of trying to rebuild that same version again. Allowed us to start breaking up pieces of the code because of the dependency management. We could start fracturing pieces off. And like I said, getting closer to that continuous delivery cycle, providing separation between our development and deployment. This is where we basically drew the line. If I go back here, this is where our development cycle is now completely separated. So instead of pushing artifacts, we were now via the automation pulling the artifacts from the repository. which for anybody that's in the compliance world, that's good. We only needed one-way access in, and it was being pulled in. And mainly that's in our production environment, which we call our CDE, which just means that we have credit card data in there, so we have to follow a whole bunch of regulations and everything is locked down. Like I said, compliance, providing access to all our deployment artifacts whenever we needed them. Again, compliance on there was a big thing for us. Made our infrastructure team very happy. On the atomic side, really, like I was telling you, it really just abstracted the work that I had already done in Automation Engine, which was nice for us. It was a nice, it added value there of the web-based tool. Easy workflow monitoring, so when QA kicked off a workflow, they could actually monitor the workflow, and also if for some reason it errored out, they could see why it errored out, and more often than not could solve their own issues. Deployments with downtime, we went from an hour to 24 minutes, mainly because that's how long it took to restart JBoss and download the artifact. I mean, that was basically it. So we kind of squeezed all the time out of there that we could. And then finally, the implementation of rolling deployments. Not all deployments we're able to do this with. Mainly the criteria are there database changes, because that's kind of our single point of contact right now, which we're hoping to resolve at some point as well. But if there's no database changes, we actually hooked Atomic to interact with our F5 appliance, and we automated that. So we would basically bleed off half the cluster, via the automation. It's basically run the normal automation of deploying that said artifact to production, bringing those back online, bleeding off the other half, and we finally had a zero downtime deployment process. So we'll do a lot of those. Most of those end up being hot fixes, just bug fix stuff that we want to just roll in. It doesn't affect the database at all, and it's provided us a way, a value add to our customers, where if we introduce a bug into the production system, we have a way of delivering a fix for that without interruption, which was really big for us. So you're going to see this slide a lot. What next? One thing that we've kind of prided ourselves on is just kind of pushing the envelope. So, in that process, we're always kind of looking for that what's the next thing? For us, it was this, automating infrastructure. I've heard actually a lot of speakers talk about it, which I think is awesome, because I think it is kind of the future, at least, from our perspective. We had to do some finagling to sell it, because the cost model is so different than traditional infrastructure, and still kind of being proved out. But for us, the low-hanging fruit with this was saving money on lower environments. There were times during the year where we would be at capacity, as far as we had 5 QA environments to be used, and we really felt a pinch certain times of the year where when we have 7 projects going on, how do you expect us to test on 5 environments? It's just not going to happen. So there was a lot of negotiation there, and obviously stifled our ability to deliver that code. So this is kind of how we sold it, and it's typically, I think it was at our capacity planning meeting, where they were talking about buying so much more sand because they wanted to spin up more environments, and planning for capacity for the next peak season. So our goals here were pretty simple. We wanted more dynamic testing environment. We wanted to be able to scale at will. I want the ability to have 0 test environments if nobody needs them and we don't want them. And really empower a quality assurance group to be kind of the masters of their own destiny. We didn't want them to have to go to infrastructure for something, or the developers for something. We wanted them to be able to continue to do their work, and no matter what they needed. The big thing too was eliminating resource constraints. We obviously at a capacity planning meeting, we're always talking about, well, more servers, more, and that real estate was at a premium. So resource savings, cost savings, transparency, these were all kind of goals of this initial project. So automation of infrastructure, we introduced, we continued to build out our relationship with Automation Engine and the ARA product. At the time, again, being a somewhat step ahead of them, which seems to be happening, we knew it was possible. We knew it was possible to leverage these two products that they had and be able to produce this. And what we kind of approach it as is, basically infrastructure as a service. It's like if there was a request, I should be able to produce a end-to-end environment for the user based on what they're deploying. So since the users were already using this, it was easy. I mean, there was no real training other than them wrapping their head around. So the environment doesn't exist until I make it exist, and then I'm responsible for destroying it. That was a big culture change. Like people still, to this day, we kind of have to yell at people every once in a while. But it's just one of those things. It's one of the, until you like really pull the trigger on it and implement it, like it's hard to explain to people. But we definitely leverage those, as our automation platform. And then we decided to go with AWS, Amazon EC2, which great CLI development, all that stuff. So it made it really easy to kind of leverage Atomic on top of. And they had a lot of their own tools for automation. We always kind of approach the idea of automation is we want it to be abstract enough where I don't care what the platform is. And that's kind of the reason we stayed with Atomic instead of trying to leverage some of the automation inside of Amazon. The cool thing about that is we can piggyback on that. Piggyback on Amazon's automation. Use Atomic to use Amazon's automation, and I'll kind of speak a little to that at the end. But basically what that provided us was no resource limits. Like you want 100 servers, you got 100 servers. Basically limitless resources there. And then it was the pay for what you use model, which was really hard to sell for us because the people doing the budget really want to know, like, I want to know hard numbers. They don't even really care how much it is. It's just they want that number. And we're like, well, it could be zero and it could go up to whatever, but it's still going to be cheaper than you sitting on this infrastructure that nobody's using. So what it really came around to was we had all of our QA environments were obviously on our VM farm, and we told them, well, instead of budgeting for more SAN, well, we can save you all that money and plus give you 4 terabyte worth of SAN back. Because we were sitting on basically 4 or 5 databases that were out there. They're enormous. And so for us, that's how we sold it. We're like, we can save you all this space, and you won't even have to buy any more SAN space next year because we're going to give you 4 terabyte back. And that's when they said, oh, okay. It was good. So pay for what you use model, like I said, is kind of nice for the applications especially for the application that we wanted to do. So as you can see on our model, we basically replaced all 5 QA environments with basically infinite cloud instances. We throttle it down because you give somebody infinite and they're going to use infinite. We give them 15, but we had that ability to expand to whatever we need to expand. But we kind of put that on management to decide, all right, how many do they really need? How many projects do we have going on, that sort of thing. So they kind of manage that, and we always push back as DevOps. Our favorite answer is no, and we just keep pushing back until they can provide a good enough reason. But basically our lower environments became these modular, really could exist or not exist. I mean, there were basically build on demand, and all driven by our automation tool. So a QA person can literally go into the ARA tool, and when they deploy the application, they'll have basically a list of components that they can deploy. Now, some of the components are required, so it's going to create them no matter what they pick. But like our core, anything really involves our core JBoss and our MySQL stack. But all of our other components are pretty optional. So depending on what the testing they're doing, they can deploy, say, if they were testing something with our LAMP stack and the PHP server and all that stuff. So they could have 2 components in the environment, or they could have 8 components in the environment. Just depends on what they're testing, or if they're doing full regression integration testing, they want everything, and they can indicate that at the point of deployment. This is just a little zoom in of kind of how we're managing this. So the approach that we took with Automation Engine was we slapped an agent on just a regular old Amazon Linux AMI that was in our cloud. We gave that server special privileges to interact with our cloud, and we used Amazon CLI to interact with our cloud. So in our VPC, the Automation Engine could basically, through the workflow, would be able to create servers, destroy servers, any interaction that we would need could do that via the jump server. And then once those components came online, they each have an agent on them that the Automation Engine can access directly and perform the deployment to. So there was kind of 2 phases. The first phase was building the infrastructure. Second phase of the workflow was deploying the application, which we already had done. Pretty early on, it was readily apparent in a world where environments could exist and may not exist. You needed some sort of window into that world, otherwise you had no clue what was going on. Whereas in our old world, the QA servers, there were 5 of them. They were always there. Like, you didn't need to know they were there. They were there. You can make that assumption. You could log into them. Well, now you pretty much had 3 scenarios. 1, it was powered on and being used probably. 2, it was powered off, in a powered off state, retaining whatever data was there for a later time. Or 3, it was empty. And so we weren't really impressed with any sort of dashboard that was already out there, so we created our own. And we leveraged Atomic to do it. Since Atomic had access to all these servers already, it already had the access we needed to basically compile the plethora of information that we have, about the cloud, what servers existed, what servers didn't exist, the components that were in each environment. Some of this stuff is pulled from ARA itself. You can actually put descriptions on deployment targets or environments and stuff like that. So people manage the environment by telling what it's being used for, who's using it, type of thing, kind of a reservation type of activity. And then you can drill down into each environment and look at what's on the component. So since these are all EC2 instances, we can use the jump server basically to pull back information about that. What OS is it? What EC2 type is it? How much memory does it have? So on and so forth. Kind of a one-stop shop for our QA departments to say, well, if something's not working, they can go out here and look at the server and see, oh, did a disk fill up, or is the service running? All of that stuff. So each component has a detailed list of system information and software information. Okay, what's installed on it? What version is installed on it? And so forth. So this was a big deal because, like I said, in an environment that is so dynamic, you need kind of a window, especially for those non-tech users. I mean, we didn't really want to give our Amazon dashboard, access to everybody, and it really wouldn't even help you because it's not formatted like this. This is kind of conceptually what it looks like, in a world where the environments are basically could be empty, like down here. I mean, it's just a representation that, this is available for use type of thing. But this was pretty big for us as far as that development. So what improved? On-demand, basically multi-purpose environments. So our PHP developers, our .NET developers, our Java developers, they could deploy an environment stack that they needed to do the testing that they needed. But not only that, it became not just a QA thing. It became a business user wanted to test some new functionality. They could deploy it themselves when they wanted to use it, test it, and then destroy it, within an hour. On-demand component refresh in record time. Mainly, where we saw the most bang for our buck here was database refreshes. They used to take 3-4 hours, and now you could get a full database in 10 minutes. Copy from production. It was awesome. Our QA people, really having that up-to-the-date data really improved our testing. And our testing cycles got quicker and quicker because they had fresh data. I can't tell you how many problems stem from having stale data, testing against stale data. So that was big for us. Endless capacity, obviously cost savings. We saw huge cost savings here because people were only using it for what they needed it for. And for most of the time, you go out there and two environments would be used. There are times where the pendulum swings the other way, but it all kind of averages out. And now that we have that data, we can then sell it easier to the business to budget for that. Complete self-service, like I said, they could build it, test it, delete it, power it off, power it on, that sort of thing, right through the ARA tool. The big thing that we saw too is the repeatability thing. Now that everything was automated and everything had the same process every time, our environment became way more stable. Like we didn't see issues anymore with just random stuff. It really kind of drove that stability home. Improved QA turnaround, obviously. They could deploy quicker and more frequently. One benefit that we came across as well is server patching, middleware configurations. Since those were pre-installed on the image, our infrastructure team, instead of updating all of the instances, they would just update the AMI with the patches that were required, and we would queue everybody, all right, if you have a JBoss server out there, go ahead and refresh that. And that would pull the new image with all the patches on it, and they could continue doing what they were doing. So that was kind of a side benefit that we hadn't even planned on, but just being that modular setup really helped. So just last month, we applied this to staging. So not only is it in our lower environments, there was basically one node for each component. Now for any of our web stacks, we can basically make that infinite. So you can have 3 or you can have 6 JBoss servers being load balanced by the F5. It added some level of complication, obviously, to the workflow, mainly around interacting with the F5. But we had already been interacting with the F5 with our rolling deployments. So it was just kind of the learning curve of learning the CLI for the F5 and how to interact with it. But we just launched this probably 2 weeks ago. And basically this replaced what was our model office environment, which was very static, very old. And now we can spin up as many of these as you want. We kind of see this as the future. And even replacing our test environments, because obviously all a test environment would be is a scale of 1. So you would have 1 JBoss server. So anything short of regression or performance testing, you wouldn't really need multiple nodes anyway. But having that scenario built in was key for us. And then finally, this went so well that the powers that be decided, well, why don't we just go to production with this? And that brought up some very interesting concepts. So we're in the process of doing this right now. And in that process, we're kind of reimagining what traditional deployment looks like. And like I said, when we came across that kind of win-win scenario of deploying a component, and a component being software, middleware, and system level type of stuff, we could really package the deployment artifact would end up being this AMI, this Amazon AMI, this image that had all the patches, all the configuration changes, and plus the up-to-date software on a server. And instead of actually deploying the artifacts to the server, we just blow away the server and create new servers. That's kind of where we're leaning with this stuff, is instead of deploying software, we're deploying an entire image. And it's definitely been a long time coming as far as kind of getting the business on board with, is this production ready? Is this ready to go? And the beauty of it is we've gotten so many iterations. Probably to date, we've done 17,000 deployments. I mean, you get really good at it when you do it 17,000 times. It's one of those things, kind of just constantly improving, constantly pushing that envelope of, all right, the process works, but say we get an error. Typically we bug that error, and then we figure out, all right, if we get this error again, what are we going to do about it? Can we write a workflow that'll solve that error and then continue on the way? And that's kind of what we approach. And over the last 2-3 years, a lot of those have been fixed. So we hardly ever see any real deployment issues or automation issues. But the big thing through that is, if you're destroying your servers every deployment and creating new servers, you get a way more stable environment. Like, you don't get those stale environments that kind of sit out there forever. And I think that's one of the big reasons we're really driving towards this, is just to have a fresh stack every time. Really lessens the possibility of having any issues, like any security issues, anything like that. So we're really driving that home in production. So like I said, you're going to see the slide one more time here. So what's next? So, we've automated infrastructure, we've automated software deployment. Everything that's out there, we've pretty much done. So where we kind of looked next was, in a perfect world, how would we deploy these, or set this up so that the automation kind of meets that next level of technology? So we started down the road of the concept of microservices. I guess, for us, nothing was more continuous delivery than having something like this, like very single-minded, straightforward services that we could deploy independently of each other, at will. So when we sat down and went through this was kind of a big proof of concept for us. We've gone through many iterations here, but kind of landed on this type of setup. So when we sat down, we kind of really looked at what was out there for our specific goal here, which was developing out this microservice architecture. So on the development side, we're looking at, we have Java developers, we're going to develop Java services, obviously. We started looking at Docker containers, which is really kind of, I always call them, they're smaller Legos. It's like virtualization on top of virtualization. And everybody's really excited about that, and we are too. We've had some good experience, but there's also still some gaps there that we're working on. We're transitioning from SVN to Git. Jenkins, we still have. We're building not only building the code, but building the Docker container from Jenkins. So the end artifact isn't actually the jar file or whatever that we're producing in the build. It's actually the Docker image that sits in our registry. And Docker registry being our artifact repository, kind of the replacement for what our Maven repository is on our Java, enterprise Java app. And on the deployment side, again, Atomic with the ARA product, probably, we've invested a lot in it, and we've kind of learned as we've developed out with that it's our orchestrator. It's really kind of what ties everything together, and we definitely will play a role in this as well. Configuration management. We implemented Spring Cloud Config so that when we do deploy the containers, we can pass it a profile, based on typically the environments being deployed to, and it'll auto-configure itself. So a very cool technology there that we've implemented. And we've just recently started digging around with AWS EC2 container service, which has made the deployment process pretty trivial. It's got an auto scale on it, so you basically can deploy something by sending it a task definition and then telling it how many containers you want deployed, and it just manages where those go. The Nginx console registrator service, the service discovery, pretty innovative. We came up with a solution for that. So no matter where you deploy the container, you're not married to a port. It just kind of, if you deploy a container, it registers with console, and the proxy knows where to send it. And then finally, the Elk Stack Elasticsearch is kind of our log management. If you're dealing with disposable type of environments, you need a place to dump your logs, because otherwise those logs are going to be destroyed. So for us, we kind of started using that. So the big thing that I want to highlight with this is, for those of you interested in Docker, what we've found is that it's kind of funny because it looks familiar. It's kind of what our template was for just working in Amazon by itself. We have our images, which in this case are Docker images and not Amazon images. And then we have basically our environments, which are our clusters. And we deploy whatever containers. And like I said, smaller Legos. Makes it more dynamic and more platform agnostic. And for us, it's shown that we don't want to be reliant on anything. If tomorrow something better than the Amazon EC2 stuff comes out, we might switch to it. So we want to have the tools in place to be able to extract something that's maybe not developing as fast as we want it to, and plugging in something else. So for us, finding this dynamic, really, this new kind of deployment methodology for us, and this is actually going in production early November. Our first kind of delve into the Docker deployment process. So this is already all automated. It's already being tested in our lower environments, and we've seen really good success with it. My 5 takeaways real quick. Your automation tool, you need to treat as your orchestrator. It's not really a worker. Not that it can't be. It can be that gap filler. For us, Atomic has always kind of been that. Like if I can't find a product that's going to do what I need it to do, I can make automation that'll do it. And I always liken it to the Jenkins product. Like I could write something like that, but if I can find a product to be the worker that the orchestrator tells it, okay, you do this, that's what you want. You want to use your automation tool as an orchestrator, and really find that best in class. All right, I need it to do this one thing real well. Like I need it to run builds, and I need it to check builds, and I need it to be scalable. And well, I'm not going to program that myself. It's already out there in open source. I'm going to use it. But what that ends up doing is it allows you to be flexible. So for some reason, if we decide that Jenkins isn't going to work for us anymore, we don't have to rewrite our automation, really. We just need to find a new product that plugs in there that basically the orchestrator can tell it, hey, do your job, and tell me when you're done doing your job. That's the biggest thing here. I think most people want that all-in-one solution, and I think that's, you don't want to marry yourself to one thing. I think we're seeing that a lot out there. But from our standpoint, we use that automation tool as an orchestrator and not a processor. So that kind of leads into the second one: seek out the right tool for the job. The third one there: never stop improving your process. There's always something that can be improved, and we're continually doing that. Use automation as a way to change the process. Like I said, path of least resistance. If you make the easiest way the right way, it's going to work. And then take time to focus on what you're doing right. This conference kind of did that for me. Like as DevOps people, we're constantly dealing with issues and not looking at what we did right. So being able to reflect on this was huge for me. Really shows how far we've come, from the very manual to now somebody that doesn't even know anything about the technology we're using can hit a button and deploy an entire environment with our software and use it. So these are kind of the things I'm looking for. Configuration management, I'm surprised we've gotten away with not having this for so long. So if you work for Puppet or Chef, I might be talking to you later. Right now, again, we're using our gap filler, which is Atomic. I have jobs written that basically do the on-the-fly configuration. So our image is kind of tokenized, so I can insert certain inputs to configure that server for the environment that it's going in. I'd like to get to the point where, again, I'm going to go out and get a tool that I can basically use Atomic to tell that tool to say, configure my environment for this environment. And that's kind of what we're looking at there. The other stuff is revolved around Docker containers, which I'm sure a lot of us have questions on. For us, the scaling is kind of a nightmare. Like trying to figure out, you're not only scaling instances underneath, but scaling containers on top kind of becomes this crazy calculus problem that is really hard to figure out. And the other stuff kind of around that same token is right now we have about 20 microservices. Now some of them have logical groupings, like they all pertain to the kind of the same information, and trying to provide an easier deployment solution for our end user. Right now they have to deploy them one at a time, which isn't a big deal because it's automated, but they have to click through and I'm going to deploy this service, this service, this service, this service. They would have to run it 20 times in order to deploy all of the microservices. And what we'd like to see is some sort of logical grouping where you could, and in addition, some dependency management, so that if I deploy this, it's going to deploy a logical grouping of those Docker containers. So it's kind of what we're looking for. Any questions? I'm sorry I ran a little long, but
I have a bunch.
Oh, go for it.
How big is your group?
The BTS department, which is our technology group, is about 100 people. I would say maybe 60 of those are developers.
No, I meant how big is the group that you have implemented your automation?
You're looking at it.
Oh, wow. Impressive.
So a majority, like I have one counterpart who is kind of my R&D guy. Like he's the guy that goes out and finds the technology and then he hands it off to me and I just chew through it. So like he was the one that kind of pioneered our reach into the cloud and kind of got me started there. And then he gave me the concepts and I went through and I figured out the CLI and automated all. And same with the Docker thing. That Docker with the console and registrator setup, like he architected all of that, and then he kind of comes to me with the finished product, and I basically automate how to do that in either EC2 or a static instance or whatever. So yeah, this is, if you haven't noticed, I'm like deep into this, like love this stuff, like it gets me excited. So
What was the effort involved when you migrated your deployment from Jenkins into Atomic? What is the work effort?
So it really was kind of completely different because the Jenkins workflow was so, like I said, it was very trivial. And if your deployment process is that, basically building your artifact and then SCPing the artifact to the server, then Jenkins works fine. And for us, it was kind of like an interim project because we really wanted to have something push button. And Atomic, it wasn't that we couldn't have taught somebody, but it was a thick client application at the time. And in order to install that on everybody's computer, just to do this one simple thing was kind of overkill.
Right.
And eventually, obviously, they caught up and web-based, and now it's all web-based. Now the new version's all web-based, which was huge. That really was the selling point. Then we're like, all right, we don't need to do this. Jenkins can just be over here doing its builds, and we can use Atomic for everything now. And I think we really needed that for a number of reasons, but the big thing was that drove us in that direction is we wanted the deployment to the lower environments to be identical to the production environment.
So was that like a
To develop that out, since I was a lot of it's extracting the knowledge from from your users. Like I was brought in as a developer, so I was already in the developer group, and I already knew, like I already gone through, I think 2 or 3 deployment processes myself. And as soon as I was introduced to the Atomic tool, I'm like, why aren't we using this? And it wasn't even really a project that was brought to me. It was a project I'm like, I don't want to spend 6 hours on a Saturday doing this deployment. How about I just let me play around with this tool and see if I can get it to work? And that's how a lot of this stuff started, because there's no initiative in the company to kind of do that. I mean, maybe nowadays there is, but at the time, they're so focused on, okay, we need to develop features for our customer. Our end customer being the people that are paying us money, and not a lot of attention to the people inside the company producing that. Like, how do we make their job easier? Because it's a trickle down effect. Like, if you can make their job easier, and then you can obviously get more done. So a lot of the stuff, I was fortunate, and that's why I love working for TASC, was because they just let me, here, go at it, do it. And when they brought me in, I told them flat out, I'm like, I'm a mediocre Java developer.
Well, let me ask the question this way. You showed your slides as like the stage 1 and then the stage 2. What was the calendar time between those 2 stages?
So from inception to, and realize that I'm also doing, operations type work of, like, if there's something on fire, it's problem solving work. I think probably 3 years.
Oh, okay.
And there were gaps in there mainly because we weren't driving it. There were downtimes. I would say, implementing the initial workflows were, I would say, maybe a month for the deployment process, because it wasn't really that complicated. It was just A, understanding the tool, and B, understanding, the additional steps we wanted to add in there. For us, it was more about, validating that consistency factor of repeating that same, not repeating the same issue, I guess. So if we had issues during a deployment, which happened all the time, that's why they took 6 hours. It's like, how did we remedy that? Like checking disk and checking services and being able to identify that needle in a haystack that is the actual problem.
The thing you created in Atomic was much more robust than what
Yes.
Jenkins.
And it had to be. It had to be. Anytime you automate something, that's what I always tell people that come to me now, because now we're a culture of that. And people are, well, why don't we just automate that? Like, great. Show me how you do it manually first. And half the time, it's like pulling teeth. They can't tell you. It's like, how can you not tell me? You do this all the time. It's like, well, yeah, but sometimes this works, and sometimes I have to jump on one leg and hold my hand like this, and then it works. And I'm just like, no, I can't automate it until you can tell me what the manual process is. And like I said, that was a majority of the work. Extracting that tribal knowledge from your developers, from your QA. Like I said, it was good because I was already ingrained in with them. I was one of them. So I didn't come in as, I'm DevOps, I'm gonna do this whether you like it or not. It was more of like, I was a developer that had to do this stuff, and I'm like, I want to make this easier for everybody here. So working with the developers, it went pretty quick, but for us the big thing was infrastructure. Automating infrastructure, I think, kind of shook them, and but eventually they realized that this is the future. Like, if you're going to be in infrastructure, pretty soon you're going to be, it's all going to be cloud. It's the next VMware. And most people, still holding on to that VM, like, well, we want security, and they're scared about it. But I remember the same things happening when VMware came around. Like, well, no, we can't go virtual. I don't even understand that. I need a physical box. And
so speaking of virtual, do you use service virtualization at all for like your credit card vendor backend stuff?
We're starting to, yeah. So the big concept there, really trying to make those tiny, very specific services. But yeah, they're starting to delve into that. It's like I said, it's interesting stuff. Not only from that standpoint, but from an automation standpoint of, all right, I got to kind of rethink deployment and getting further and further away from that, deploying that ear file. Like pretty soon, that's not really what it's going to be about. Hopefully, yeah. Go ahead.
So this is beyond deployment.
Sure.
Have you guys thought about the monitoring, alerting, and remediation, troubleshooting side of automation?
Yeah. So the nice thing about Atomic is that a lot of that stuff's kind of built in. We started implementing a few projects which we started plugging into. One being Alert Central. I'm not really familiar with it, but it's kind of our management for things you would get paged for. And the nice thing about using Atomic is we were already sending emails. Obviously, if something was wrong, or we could send alerts via the console as well.
If your workflow is not
Right. Yep. And the beauty of it, it's all kind of visual. And then if you design it correctly, like I always try to make the smallest chunks possible. So just think of your workflow as a series of jobs. Either in parallel, however you want to do it. I always try to make the job do like one thing. Like that's all I want to do. Because if it errors there, I want to, the nice thing is that you can do some really sophisticated kind of reporting and error handling and stuff right in with the workflow. And a lot of the stuff that we have like that, I love stuff like that. Like when we have problems, I like it because it identifies something that I can solve. So like our common problems, like we don't even hear about anymore. I just write contingency workflows that if this happens, then do this and then continue on your way. And it really kind of remediates, 90% of your issues. You're always going to have that fraction that are new. But we're constantly, like I said, constantly going back to that original workflow and saying, all right, how do we resolve this issue so that we don't have to hear about it? Go ahead.
So is Atomic more of your workflow engine? That's the core of what it provides?
It's basically what it is, yeah. Like I said, it's the orchestrator. Like, that's simplifying it. You can do pretty much anything you want with it. Like if you wanted to build your own Jenkins server, you can make it do that if you're good enough at scripting. But again, you don't want it to do that. You don't want it to do that. You want it to be the person going around and saying, all right, you do your job, and the beauty of it is it's platform agnostic. So like if I need a Windows job to trigger a job on a Linux box, you can do that. I mean, that's important stuff. And if you get really good at bash scripting and PowerShell, like I have, you can literally make it do anything. Go ahead.
Just two questions. Were there concerns about the differences in the infrastructure when you do QA up in the cloud versus your on-prem?
So I sat down with infrastructure and really went through like what they were using, and the big problem there was a lot of inconsistency. So what I did was kind of drive home those consistencies when we went to the crowd. Me along with the infrastructure group kind of sat down and really talked about, all right, what is going to be our template? And because we knew we were going to go through enough cycles where if we did find any issues with any changes that we did make to that, core, whatever OS we use primarily CentOS, and whatever kernel version we were going to use. We didn't really have too many problems, but also like our platforms aren't really that complex. I think we could have we kind of just went with latest and greatest and went from there. But as we move closer to production, that's one of the things that we really kind of focus in on, because if it's not working in a lower environment, it's not a huge deal. I mean, we have time to remediate that or whatever that is, but definitely what we're trying to do is basically push that consistency all the way up to production. And now that we finally sold the powers that be to take production to the cloud. I mean, like I said, we've gone through so many iterations in the lower environments, and now in the staging environments, we're already, getting that under our belt that, we'll flesh those issues out, no problem.
So you've never seen something that in production you found an issue that was related to running the virtual stack on like HP hardware as opposed to whatever Amazon is doing?
Nope.
Like that?
Not so far. I'm not saying it can't happen. You're right. It's definitely a concern. But like I said, that's why we've always been pushing. Like, well, even though they didn't really think that we would go to production, we were like, yeah, we're going to go to production because we want that consistency. And that was the driving force between us going to staging, because we wanted to keep our staging environment the same as production for that reason. And finally, they kind of gave us the green light to do it, and we implemented staging, and we've been using that for maybe a month and a half now, and it's light years faster than, it's on par with production, and it's not even, as far as performance goes, and it's not even remotely as big as far as memory and CPU. So we're seeing better performance because of some of the tuning that we're doing in our VPC. So you can put them in placement groups, which kind of optimize the network between, say, your database and your web server. And we're seeing huge gains there. So, in addition to all this stuff, our testing team, our architecture team has really been putting it through its paces as far as performance and concerns like that of differences in hardware. But the idea was always to push everything to production or into the cloud.
You said 10 minutes to run a database, restore it into does that include getting into the cloud?
So what we did was we hooked we created a MySQL instance in the cloud that was a slave off of our master. And so we actually have that automated where every day at 4 o'clock in the morning, it powers on that instance. It starts replication. And then as soon as replication is done, it powers it off and snapshots it.
And you use
Yeah.
your automatic.
Atomic does that, yeah.
Yes.
Yep.
Thank you. Okay, so you don't use anything like Delphix or anything to do database flooding?
Nope. I think it takes, because we leave it off to save money, because we're not going to just leave the slave up there running, just keep replicating when it takes, literally we power it on, and the 24-hour period usually takes like an hour to replicate, and then we just shut it back down and snapshot it, and then, that creates our MySQL component image, and then, database refresh, 10 minutes. The entire environment, it's 20 minutes tops. And that's with a full stack of everything. It's really the database is the longest running one because it's so big.
Yeah, that was the question I was
Yep.
going to ask, is how you did the database thing, because but our databases are much bigger, so it takes us like 24 hours.
Oh God. How big are they?
I don't even know at this point, but they're like getting close to terabyte
Yeah.
size. So
Yeah.
it's a big challenge we have, like you were talking about stale data, and it's like how do you refresh those?
Yeah, and that was a game changer for us because people were afraid to refresh a database because they didn't want to waste all that. One of our 5 environments would be down for 3 hours. That's testing that could have been done, but at the same time they were doing a disservice because testing against, especially batch processing, if you run it against data that is 3 days old, it's just like you might as well not even do it because it's so out of whack.
And plus there's, I guess, the latency between your hosting environment and
Right.
us, right?
Yep.
Which also is a factor.
So that really, just that 10-minute database refresh is huge for us. Any other questions? Well, thanks for hanging out. Go eat lunch or something.
Yeah.